Today we are going to learn a little bit about spacecraft entry guidance. So let me get my mouse pulled up here. What we're going to do first, let me write this out, if my mouse would work. There we go. Spacecraft, entry. So first let's talk actually about the general problem of spacecraft that are coming through the atmosphere. So when you're in outer space, specifically around Earth, so if here's Earth and you are a spacecraft, say right here, now frequently in TV shows or movies it looks like things in outer space aren't moving very fast at all, but it turns out things in space are moving very, very fast. Things like in low Earth orbit, for example, typically move on the order of 17,500 miles per hour to say 12,000 miles per hour. Now that's really, really fast. So like the 17,500 miles per hour means you could cross the United States in about 9 minutes or so. And it turns out how fast you're going depends on how far away from Earth you are and some other things. But in general, the principle is the further away from Earth you are, the slower you go. The closer to Earth you are, the faster you have to go to stay in orbit. So here's the spacecraft's orbit around the planet. Somehow you need to solve this problem of getting from the orbit, going really, really fast, to getting down to the surface of the planet. So the hard part of this is you have all of this energy. So if you remember from physics, energy, well specifically kinetic energy, is 1/2 your mass times your velocity squared. But if you also remember your potential energy, that is equal to your weight, mg, times your height, h. And this is your altitude above the Earth's surface. This is the acceleration due to gravity, and this is the mass of your spacecraft. So you can see when we are going really, really, really fast and we are really high up from the Earth's surface, we have a whole bunch of kinetic energy. So this is kinetic energy, and this term is potential energy. Turns out when you're in outer space, your energy is dominated by this term. You have tons of kinetic energy. You have so much energy, in fact, that if you tried just to re-enter through the Earth's atmosphere, if you just absorbed it all as heat, it would melt aluminum. It would melt steel. You have so much energy that you could melt metal and you could vaporize it. And that's actually what happens to things like meteorites and bits of space junk that falls into the atmosphere. Most of it burns up because it's going so fast, it absorbs most of the heat and it actually burns up. So the challenge is, how can you get rid of all of this energy by the time you get down to the Earth's surface? So once you get to Earth's surface, ideally, if you are an astronaut, you want to be moving very slowly. So you want your velocity to be around 0. So this symbol means around. And you want your altitude, h, that of course is going to be 0 when you splash down, or wherever you land. You're going to be at 0 altitude, assuming that you land at sea level or landing at the surface of the Earth. So the challenge is how do you safely get rid of all of this energy in such a way that you don't burn up and that you don't squish the spacecraft and make it break due to g-forces. So here are some of the problems. You have heating, and so heating is very hot. You also have g-loads, which is very uncomfortable for crews. And frequently, even if you don't have a spacecraft on board, or if you don't have people on board your spacecraft, you have g-load limits that prevent you from building up excessive accelerations on the spacecraft. So the spacecraft only might be able to support 20 G's of acceleration. And when I say 20 G's, I mean 20 times the acceleration due to gravity. at the surface of the Earth. So 1 g is what we feel on the surface of the Earth, but 20 g's feels like you have 19 other people sitting on top of you as you are feeling this acceleration. So obviously you feel like you're getting squished. When you get these huge g-forces, bad things start happening to people's bodies. Things like they start blacking out, or blood stops flowing to the brain. That causes blackouts or grayouts. Lots of bad things can happen, and too much G's or too much acceleration can be actually fatal to humans and animals. So we have to make sure we limit how much acceleration builds up on the vehicle. The other thing, this heating problem is actually a pretty tough one as well. As you're coming back in through the atmosphere, you hit the atmosphere really, really hard, and it starts transferring heat to your spacecraft. And your spacecraft has to have some way of protecting itself and not burning up. So we will talk about that in the next video. But this gives you a general idea of the basic problem of spacecraft entry, which is slowing down and getting rid of all of this huge amount of energy and landing safely on the surface of the planet. Thanks.